Right. Good evening. Wrong. Some questions are there on the liquid pressure, hydrostatic pressure. 3 questions are there that we have to discuss. There were 3 questions. Right. Like it. You don't have it. Go with your cards. Look at these questions. I'm reminding the theory first. We learned about pressure. Pressure, it is the force over a unit area. Force over a unit area when you come for solid pressure. Solid pressure is equal to P is equal to F over A. P is equal to F over A meter. That is for the solid pressure. That is for the solid pressure. And the liquid pressure. P equals H rho G. Okay. 2 formulas we learn. And today we are going to speak about the questions related to this. So you see, find the pressure exerted by a 25-meter deep water column, density is given. How do we find out? P is equal to H into rho into G. This is not letter P, it's rho. Look at this. Okay, we'll look at this now. We have a question before this. Calculate the pressure at the bottom of a mercury column 25 centimeters deep. 25 centimeters deep. Okay. So that means from the upper level 25 centimeters you are going down. And below the 25 centimeters you have to measure the pressure. You have to measure the pressure. How to take the pressure? P is equal to H rho G, the same formula. How much is the height now? Now, if this is the level that you are concerning and this is the point you consider, from the bottom when you take the physical quantity, that is called D. It is a depth. From the point D when you go up, it is the height. So, seems to be the same thing. H is given 25 centimeters. I can't apply centimeters. I have to divide it by 100 to make it meters. Multiplied by how much is the rho given? Density of mercury is given as 13,600 kilograms per cubic meter. Right? Kilograms per cubic meter. And then I have to multiply this by gravity, which is 10 ms minus 2. 10 ms minus 2. So how much is my answer there? Okay, give me the answer quickly for this. How much do we get the answer here? How much? 25 over 100 to make it meters. Multiplied by the density, multiplied by the gravity. So how much should be the total answer? Hurry up, please. Change. Straight away, even you can write 0.25. Okay, give me the answers. How much is it? It's 34,000. And the answer should be in pascals. 34,000 pascals. 34,000 pascals is the answer. Hurry up, take your dudes now. Take your dudes now. 34,000 pascals is the answer. Okay. So that is P is equal to H rho G. Right. Question number 2. Question number 2. Find the pressure exerted by a 25-meter deep water column. Now can you see 25 meters given. So do I want to divide it by 100 to make it meters again? No need, right? So straightly I can write it as 25 meters. 25 meters. So the second question here, 25 meters into how much is the rho? Rho. What is the symbol? Rho. Rho refers to density. How much is the density given? 1000 kilograms meters. How do we read this? Kilograms per cubic meters. Into gravity is 10, right? So when you multiply this, 25 with 4 zeros are there. 250,000 pascals. 250,000 pascals. Okay, 250,000 pascals. Please correct your answers. Hurry up, hurry up. Question number 3. The depth of the certain region of the sea is 10 meters. Find the pressure exerted at this region by the seawall. So again, how do we take? P is equal to H rho G. What is the depth given? I told you depth from the top to bottom means bottom to top, that is the height. Anyhow, below the depth only we are going to measure the pressure. So height is 10 meters into how much is rho given? Usually water is 1000. When it comes to salt water like in sea, it gives you 1050. So 1050 kilograms per cubic meter. Into gravity is 10 ms minus 2. How much is it now? 105,000 pascals. Very easy. 105,000 pascals is the answer. 105,000 pascals. Okay. Right. It's a homework, man. The next theory we are starting on now. Transmission of pressure through liquid. Transmission of pressure through liquid. So what is the theory here? Look at this. Look at this. Only once. So please listen. Only once. You have to listen. Now I do have a sort of concept here. We term it as a hydraulic press concept. What is the concept? Hydraulic press concept. Okay. Hydraulic press. This is the concept. Hydraulic press concept. Okay. Now look at this. Observe the diagram first. Your observation is important. Now we see the same liquid is there here. If it is the same liquid, the liquid's nature be the same, liquid's density be the same. Okay. Now look here. And we do have two ends. One is surface area having a smaller surface, the other one is larger surface. Okay. And I do have the piston. I do have a piston. So this is the piston A. It is the piston A. Right? And this is the piston B. Piston B, like a syringe. Like a syringe to put. Now you see, piston A, I am giving you the surface area as 10 square centimeters. Surface area of A. Capital A is surface area. Look at it. Capital A refers to guys surface area. Surface area of the piston A. Surface area of the piston A. And the surface area of the piston B. Correct? Surface area of the piston B. I am giving you. Is it 200? 200. Correct? 200 square centimeters. That is the surface area of the piston B. Okay. You understand this point? One is having a lower surface area, the other one is having a larger surface area. And what do you do? You are going to apply a force here. What is the force? The force at the surface A, which is 20 Newton. How many newtons? 20 Newton. Now, usually when you are having such a concept, such a instrument, one side when you push down, the other side water comes up, right? So now what are we going to find? We are going to find out what is the force given up. How much is this at B? The force at B. That is what we are going to find out. You understand? So we are giving a force 20 Newton at the smaller surface area when it is transmitted through the liquid, because the liquid can transfer the pressure. The pressure will be transferred. And now we consider at the same point, can you see? Liquid level is same. And we learned already in the liquid pressure earlier. Any points you consider on the same level will be having the same pressure. So the points on the same level are having the same pressure we learned. So the pressure here and here would be the same, and that is transferred like. So what is the pressure you are giving down here is PA, and what is the pressure coming up here will be P. So why I am using A and P? Because points are A and P. Now what we do? Look at this. I'm going to take PA. First I am finding out PA. Pressure at A. How to find out the pressure? Pressure equal, if it is a solid, force over area, right? And I'm giving the pressure by this piston, right? It is a solid piston. So I'm going to find out the force over area I'm applying. I'm finding out the pressure. Is that clear? P is equal to F over A. I'm writing is A to show that is piston A. Piston A. So now tell me, what is the force here? 20 Newton dividing by, what is the surface area? 10 centimeters square. We learned that area must be in square meters. Area must be in square meters. But here I am not converting since it is a theoretical part, and moreover, both the sides are given in square centimeters. Anyhow, it would be cancelled. When you are dividing both the sides by 1000, it would be cancelled. So I am going to take it as centimeter square here, right? Since it is a theory. Now 20 over 10, how much is it? 2 Newton. Centimeter square, you take it centimeter square minus, okay, centimeter square becomes minus 2, square is minus. So what is the idea of this? The force you apply is 20 Newton over 10. 20 Newton over 10. Then how much will be the force over 1? 2 Newton per square centimeter. You understand? So 20 rupees among 10 people you are sharing means how much each person get? 2 rupees. Correct? So 2 rupees, 2 Newton per square centimeter. That is what the force, that is what the pressure acting. Did you understand? Is that clear? Pressure equal force over area. The pressure acting here is 2 Newton per square centimeters. Did you understand? Clear? Right. Then what I do? According to the theories we learned now, on the same level, pressure will be same, and that the pressure is transmitted by this liquid. Okay. So here I am writing pressure A is equal to pressure B. So PA is equal to PB. PA is equal to PB. Pressure at both the points are equal. Whom I want to find out? FB, right? So what I am doing now? I am writing PB is equal to force at B dividing by surface area of B. Correct? Correct. I want to find out FB, so I am making FB subjected. So PB into AB. Correct? What did I do? I am taking this A here, so I can find out FB, the force at B. So look at this now. How much is the pressure B? Pressure A is equal to pressure B, right? So pressure B should be also equal to 2 Newton per square centimeters. Am I correct? Correct. So I'm applying that here. 2 Newton per square centimeters. Now the person, 10 people were there. Look at this. 10 people were there. Each person get 2 Newton, and that the pressure is transmitted here. And how many people they are having here? 200. Each person to be given with 2. 200 people are there. So surface area is 200 square centimeters. So 2 into 200, how much will be the total force? 400 Newton. That means giving a smaller force at a smaller surface area. Giving a smaller force at a smaller surface area. Keeping the same pressure the other side, in a larger surface area, the force will be high. Force will be high. Smaller force, smaller surface area, larger surface area, larger force. That is because of the pressure can transmit the liquid, and that is our topic. Transmission of pressure through liquids. Clear about that? So where do we use this? You might have seen in the garages, auto repair centers. Okay. So giving a small force, might be they are pressing up with the button made buttons are there now, right? Okay, giving a small force over the button, the entire vehicle would be lifted up. Okay, for these repairs and all, that is how it happens, right? So how is it happen? Tons of kilograms sometimes. Okay, thousands of kilograms sometimes. So how is it happening? This is because of the smaller force is given at a smaller surface area. It is transmitted by the liquid over a larger surface area. It is shared. So the surface area is high, force will be increased. So more the force, now the object will be lifted up easier. And the what do you call the hydraulic jack concept? Hydraulic jack. Can you remember earlier? Last week also we discussed about that vehicles being stopped in a corner where they have to be lifted up, maybe for a repairing or maybe for a change of these fabrics. What happens? A small jack we are using now. There what we do? We are giving a small push. We are giving a small push. Giving a smaller push, we can lift up the vehicle. Okay. But the same thing, without that, the same leg, same push you give to the vehicle, would it be lifted up? Can you do that? No, you are using the vehicle jack. Okay. You are giving a smaller push by your hand, let's see. You are giving a smaller push. You can lift it up. Same hands, same push you are going to try now. Can you lift it up? Can't. Why? Because the force you gave has been increased number of times because of this concept. Because of this concept. A bus driver, okay, or a van driver, whatever the vehicle, you drive fast and you apply the brake, the vehicle stops. Okay, the vehicle stops. So the bus driver stops the entire vehicle, the large vehicle along with the passengers, just because of one leg. Same thing can you do in front of the bus when it is coming? So he's putting like this. Can you stop? Because the same leg, giving the same force, can you do that? No, why? Because the force he gave over the brakes, acting as a pressure, will be transmitted by the oil, the liquid over there, and will be acting over a larger surface area in our exhaust system, the brake system. So it increases the force. Increasing the force by number of times, it stops the vehicle. Did you understand that? Clear? So it is not just a small act we are doing, but it is multiplied because of this physical theories. Clear? We'll note this down. And on your tube, guys, look at this. This is the only part. First, you have to write. You have to fill it up on the diagram. And below the diagram, can you see? There are two spaces given, right? Two spaces given, right? Okay. Look at this on your tube. Here there's a space, right? There's a space here. Afterwards, here there's a space, right? So look at this cable. Here, we write the first part. Okay. Don't ask again. This part we write here. And below that, there's another space. Above this topic, another space. There we write this. Okay. You can write them straight. You can write them straight. Or you can divide them into two sides and write. Okay. Go ahead. Make it fast, please. Yeah. Syringe-like structure. Imagine on a syringe you're applying a force over. That structure is called a piston. No, on the same board. Turning on the light. Light or fan? Hurry. Write it down, please. Write it fast. Mark the arguments properly, take the notes clear. Yes. Yeah, I gave it today. I gave you a work to be done. Huh? Who said? This week I said. Last week I said. Last week I called today. Take note. Under short time, then I will go to the next constant design. Voice. Okay. Yeah. Right, moving to the next one. And Arif? Azam. What are the applications of these transmission of liquid? Look here. So you can see here, which we have discussed now, lifting up of vehicle using a hoist, or using a vehicle jack, we are lifting it up. Giving a small force over there, a larger force is acting by the other end. So it can be used to lift up the vehicle from the vehicle. And when you come to the auto service centers, okay, the service centers when you are taking one, you can see a smaller surface area is there that we are giving the force, right? And that the force gives the pressure. That pressure will be transmitted via the liquid and will be acting over a larger surface area, increasing the force. So the vehicle would be lifted up. So this is also following up hydraulic press concept. And here when you come, right? So now you apply the force over smaller surface area, right? Two cylinders are there, slave cylinder, master cylinder we say. So anyhow, when you apply the brake over there, that the liquid would be transferring the pressure. Pressure would be taken by this piston it is giving you, and the pressure would be taken towards the brake pads having master cylinders. Over there we do have the brake and everything. So within this system, in a larger surface area, increasing the force, it is acting. You are giving a smaller force, by over a larger surface area, it is increasing the force. So by that force only the object will be stopped, the vehicle would be stopped. So all these are following up for hydraulic press concept. I have summarized this and explained you the important parts. But still I have given you the description over there on your tube. It's your duty to read. You have to definitely read it. Okay, without reading, don't say it was not there, this was not there. It has to definitely read. Okay, fine. So next we come for the third topic, pressure exerted by gases. Pressure exerted by gases. Now earlier we learned pressure by solid, that is the force acting over a unit area of some surface. Pressure due to liquid solid defined, that is the pressure given by the liquid column above the fluid. Any point you consider above that point, what is the liquid column pressure? By that liquid column, there will be a pressure. That is called the liquid pressure. Same way when you come, okay, pressure exerted by gases, there are two ways the pressure could be. What are the two ways? One, by the liquid column, by an air column. something like the liquid column. By an air column, there will be a pressure unit. So this gaseous pressure unit, there are two types. The gaseous pressure unit, two types of gaseous pressures are there. Have a look. What are the two types? In atmosphere, anywhere, at any point, okay, you take. There's a point, let's say, by the air column above it, by the air column above it. This air column above the point will be having a weight, right? Because it's a matter having space, having mass, so it will be having a weight. By the weight of the air column here, there will be a pressure given. This pressure is called, okay, this pressure is called atmospheric pressure. Okay, this is the atmospheric pressure. Atmospheric pressure. This is one thing. And this may be artificially also made. This is the natural one, right? Artificially also, within an air container, you can fill up the air and you can measure the pressure at a certain point. Listen. Okay. So, this is about the first point. First point, atmospheric pressure. Second point, imagine a balloon. Yeah, air filling a balloon, you are going to take with air. You are going to fill up air. Just like water, when you are filling up, when you fill up a balloon with water, water also gives the pressure. Same way, when you're gonna take a balloon, okay, and let's say it's tied up, so the air inside gives a pressure to the wall of this balloon, to the wall of the balloon, okay, and it's trying to go out. It's trying to go out, but nowhere it can go out. So it gives a pressure over there. Anyhow, it would be hitting on the walls. So this pressure is called compressed air pressure. What air pressure? Compressed air pressure. Compressed air pressure. Now you see this compressed air pressure, somewhat you take it open, you untie it, whatever air leaves out. And when you keep your hand, you can see in a pressure, it releases out. The pressure cooker also the same. When it is, there's a lid, there's a sort of port. When it is adjusted, the hole becomes exposed, so the air leaves out, giving a high sound also. And when you come right, what we call these liquid bottles or something bottle, also having a high pressure of gas inside. Not sure, but it's giving us out, giving us out. So you see, this is because of compressed air. So compressed air leaves out, releasing the pressure. Did you understand? So these are the two types of pressure here, and basically they are going to speak about this atmospheric pressure. Atmospheric pressure. So let's write down below the gaseous pressure you are writing. The pressure exerted at any point. The pressure exerted at any point. The pressure exerted at any point in the atmosphere. In the atmosphere. The pressure exerted at any point in the atmosphere by an air column above it. By an air column above it. By an air column above it. Or by compression of gases. Or by compression of gases. Right? Or by compression of gases. Right? Fine. Can you see in that same page you will have a sort of diagram? Look at the diagram over there. Read that activity given quickly. Quickly read that activity. There is a YouTube activity given. Can you see? A YouTube is given there. YouTube means U-shaped tube is there. Can you see? Quickly read it. Read it quickly. I want you to read it, please. Read it. This is what the diagram given there, right? Have a look. This is what the diagram. Look at this. Now, initially when you take this diagram, okay, X and Y are there. X and it is a U tube, U-shaped tube. Two arms are there, X, Y. Both of them are having the same level. This comes in question, so listen carefully, otherwise go out. Two arms are there, X, Y. So both of them are exposed out. Atmospheric pressure at on. Atmospheric pressure acting on. So the atmospheric pressure is given over there, both the sides. And wherever you take the atmospheric pressure, probably it seems to be the same. Okay. So I'll mark it as PATM, both the sides. PATM. Pressure, atmosphere. Or P node or letter pi used either this way or this way also it could be given to indicate atmospheric pressure. So the atmospheric pressure is same. And that is why giving an equal pressure, both the levels are on the same. Both the levels are on the same point it is given here. Same point. Right? So both the levels at XY arms are same here. Then what we do? I'm taking compressed air balloon. I'm connecting it over there. So earlier only the atmospheric pressure was there. Anyhow that gases are there inside, right? So when you before connecting this, anyhow those gases are there. Right? Now along with that, another balloon you are connecting. Now what happens? Once you untie this, it is also giving the pressure, right? Due to the air compressed is leaving out, there would be an additional pressure given, right? Now what I can observe, the level which were equal earlier, from this level it goes down. It comes to this point. Let's say the height here is h. How much reduction is h? So the same amount from here. This was level earlier, right? From the same amount, it could be increasing at this point. So it was x and y earlier. X and y earlier. Now, because of the additional pressure, what I can observe, the water level from x goes down by height h, length h. And the other side, from the level y, that the water level goes up by the same length. But to be used as the same length, it should be an identical U-tube. One is smaller, the other one is larger surface area, won't work out. Same surface area. They're not in the same level, it will be increasing and decreasing. So, this happens until the pressure is equalized. And this diagram, let me take it in. I'll take a diagram here. So here initially, this was the level. Initial level was this. I'll mark it as x, y. Okay. So at the first case, let me take the point 1. Don't write anything, please listen. In the first case, the pressure given at x, Px, will be equal to Py. Why? On the same level, on a liquid, pressures are equal. So pressure at x and pressure at y are equal, and that is because of whom? Atmospheric pressure. Why? Atmosphere is equal. So I'm making it equal to pressure ATM. Pressure ATM. So how much the pressure ATM is, atmospheric pressure is, the same amount will be there x and y. Did you understand that? Understood that point? Why? Both the sides are exposed to same air. Next, what I do? Second case. I'm going to fix a balloon here. Right? So I'm going to fix a balloon here. Now this contains compressed air, right? It contains compressed air. So once you untie that, air leaves out. So I'll take it in a different color to show the second instance in the same diagram. Now what happens? Earlier only the atmospheric pressure was there, but because of compressed air pressure, this level goes down. Let me mark this level now. Okay, as x dash. X dash. Got it? So, what is the height reduced? Same height is increased. Same height is increased. I told you right, what is the level it goes down, other side same level goes up because the identical U2. So this should be an identical U2. Yeah, the surface area is same. So now the water level will be at this point. Let me take it as y dash U. So earlier x and now x dash, y and y dash, y and y dash. Now look at the point. Look at the point. So here, if you consider this point, anyhow we don't have a liquid right? Because the liquid level has gone down. Now let me consider these points. Okay, these points, right? So now this is the water level gone up. Water level gone up. I'm checking out with this point's pressure now. This point's pressure now. Now look at this. I take it over, and I'm replacing it by it. Okay, you understand what I did? I just took the name out. I just took the name out. The labeling out. So I label this point as x dash, this point as y dash. What I'm going to do? I'm going to check out with the pressure now. Px dash is equal to Py dash anyhow. Why? Because same level, right? Do you understand what I'm saying? Earlier this was the same level, x is equal to y. Now also they are the same level, bit lower, x dash is equal to y. But look at the point. Is it the ATM only here? It is not only the ATM here. It is not only the ATM here. Okay, ATM means atmosphere. Pressure at atmosphere. Not only the ATM we are taking here. Why? There is ATM plus. Can you see there is a liquid column here? Which is the liquid column drop down. Same liquid column has been raised up, right? Okay, and it is continuously there here, right? So now earlier I explained about one point. So let me take these points now to make only the important ones. Okay. Now look at this. This is the total height, correct? Can you see this is the total height of the liquid column, correct? Can you see that? Total height of the liquid column is this. Now y dash when you consider, what are the pressures given at this point? Pressure due to gas plus the pressure due to the liquid column, both of them are active, right? Am I correct? I am standing on there here. Because of my weight, there is a pressure. If I am having a bag or a set of books over my head, that could be all sided, right? Likewise, there is a pressure ATM by the books, and there is another pressure because of my weight. So the weight of the liquid column also exerts the pressure. So earlier we took in the previous case only ATM because no one else was there. But here we're gonna take it as ATM plus okay the liquid pressure. Liquid pressure. Pressure due to liquid. Pressure due to liquid. Did you understand that point? Is that point clear? So first case only the ATM was there. Second case at this level where the water level is up, the liquid level is up. By that liquid column also there will be a pressure. So the total pressure at x and y dashes will be equal to ATM plus liquid pressure. ATM plus liquid pressure. Did you understand those 2 points? Points clear, right? Okay. So the theory given here is what I have taken at once. What we do? Take your writing book. Take your writing book. Take the point as gaseous pressure first. Listen. First listen. Take the point as gaseous pressure. Okay. After the gaseous pressure, boys, here, take the gaseous pressure node in one, and the next page or down below this. Take this point, pressure in a U tube, okay, U-shaped tube, U-shaped tube. Take the note, and I prefer you to use 2 colors as I have used here. Okay, any 2 colors, but the same way you have to note it down. Hurry up. Make it fast. Turn on the light, please.
So look at next point now. Atmospheric pressure. What are you doing on this time? Huh? Maybe coming in the questions. Okay. Maybe coming in the questions asking you to find out the pressure at this point. Then how do you find out? You have to take the pressure of ATM. It would be given either it would be given or else you have to find taking some data. For that you have to add the HOG pressure. Right? Pressure at the liquid means that is HOG, right? Can you remember? Liquid pressure is equal to H into rho into G, right? Height into density into gravity. Okay. So data should be given in the question. You have to multiply and get the answer. So both those pressures you have to get the total. And that is the same pressure will be there. Actually, the question will be asking you how much will be X dash. That is the usual way. They ask you how much X dash. But here directly you can't find out because these data is what we give. Then what you do, take the line here, check it if there is anyone given in the question. Probably they will be giving a letter here. And above that, what is the liquid column height, gravity, density? Take to find out the liquid column pressure.
at the atm pressure of atmosphere, you can find out the y dash and you're gonna make it equal to x. That is how you have to end up the answer. Clear? Okay. So one side you have to find, you have to replace it into the next step. Right. Atmospheric pressure. What is the next topic? Now I told you two types of pressures are there. One is the atmospheric pressure. Major example for this. Any point. Even we people experience with that. So when we are exposed to air here, all these points, the air particles, by the air particles, that's the pressure given over our body. Right? So this is atmospheric pressure. Atmospheric pressure. So when you come for the compressed air pressure, that is because of the air compressed within a container. When you are taking a gas cylinder, even the gas cylinders we are using okay, only one port is there where the pressure could be leaking. Okay, when you open it up, it will be releasing out the gas. Okay, otherwise the whole gas inside gives a pressure. So that is the gas pressure over there. Did you understand that? So this is the difference between these. Okay, and related to these compressed air and all, some other theories are there. Those theories we are not learning at the moment now. Right. So atmospheric pressure. Let's write there. The pressure exerted at any point in the atmosphere by the weight of air column. The pressure exerted at any point in the atmosphere by the weight of air column above that point. By the weight of air column above that point. Above that point. It's called atmospheric pressure. It's called atmospheric pressure. It's called atmospheric pressure. So related to this atmospheric pressure, there was a person called Mercury. Okay, he was an Italian scientist. He was the person to contribute towards this theory. Okay, so the equipment used to find out to measure this atmospheric pressure, we name it as Mercury barometer. What barometer? Mercury barometer. Two barometers are there. One is Mercury, the other one is Aneroid. What are the two words? Repeat the words. Mercury barometer and Aneroid barometer. Mercury barometer, Aneroid barometer. Right. So because two types of pressures we learn. Okay, right. Look at this. Now, this is the Mercury barometer. There is a Mercury barometer. This is also a possible question. What it says now here, when you come, we do have Mercury in this lane. What are we having? Mercury. Now this one, it was a long tube. It was a long tube. The tube is about 1 meter in height. What is that length? 1 meter. 1 meter means 100 centimeters. Okay. So initially it was totally filled up. Initially it was totally filled up. Totally filled up. Right? Totally filled up means totally it was filled up with mercury. And what we do? We have another trough, another container having mercury over there. And this tube filled up with mercury 100 centimeters. 1 meter length. We are going to make it upright down. And we are going to connect it over there at this point. Okay. So this length here is 1 meter. How much is it? 1 meter. 1 meter. Now what I do? I'm using this setup at the sea level. Sea level means closer to the sea. Now where we live in, the terrestrial environments are a bit higher than the sea level, right? Okay, bit higher, bit above than the sea level. Usually when you are taking the sea coastal environment, up to 1 meter like height we are in. Okay, up to 500 meter, 0.5 meters to 1 meter height like we are in. So the sea level is down. Even you are going for the sea coastal environments, coastal areas closer to Colombo, still you can see Golf and all you can see, right? Above, below the point. So we are above, about 1 meter height. It's not exactly one, maybe within that range, right? So at the sea level, when you measure, when you do this setup, what you can observe is, guys, now it was mercury up to this level completely, right? When you keep it, okay, here these arrows are showing you the atmospheric pressure because this layer is directly exposed to air, right? So the atmosphere gives the pressure, atmospheric pressure, right? Now what I can observe, after some time, the mercury column drops down. Mercury column drops down. How much it is dropped down? It drops down by, actually, this is called upward meniscus. What meniscus? Upward. When you go for any other liquids, we mark it downward. Any other liquids level, we mark it as downward medicines. And this is the point we have to take the reading. When you come for mercury, okay, when you come for mercury we are taking an upward meniscus. This is downward meniscus for other liquids. Okay, other liquids, and this is for Hg. Hg means mercury. And this is the point where we get the measure. This is the point where we get the measure. So, up to this, when you're gonna take, you can see there is a drop off. There is a drop off 24 centimeters. How many times you repeat that? Approximately the same value, 24 centimeters it is. That means what is the remaining of the height? What is the height remaining? 76 centimeters, right? Out of 100. Out of 100, this is 1 meter, right? It is 1 meter. So out of 100, when it is 24 drop down, what is the remaining height now? Remaining height is 76. Remaining height is 76. Understand that? How many times you do this closer to the environment, the sea coastal environment, you can see the same lake. Drop will be 24, remaining will be 76. So now, initially it was filled up with mercury and it is dropped down, right? Who is there here now? No one is there. Can air be? No. Why? It was totally filled up with mercury and this is also inside the mercury column. So no way the air could move. Then who is there here? It is a vacuum. It is a vacuum. And since it was contributed by, it was, this theory has been revealed by torically, we name it as torically vacuum. What vacuum it is? Torically vacuum. Torically vacuum. So it is a special name given for this, torically vacuum. It's totally vacuum, no solid, no liquid, no gases there. So, as I told you, how many times you repeat the same 76 centimeters argument? Now you see, these points you consider, they are on the same level of the liquid, right? Should be having the same pressure, right? And this point you consider at the bottom of the 76 centimeters is also in the same level, right? Now you got the point. Same level should be having the same pressure. Here the pressure given is PATM, pressure atmosphere. And here the pressure given is because of whom? Liquid pressure. You understand my point? Clear? All these points completely throughout this level. This is because of the atmospheric pressure. And here the pressure because of the liquid column is pressure given by Hg. Pressure given by Hg. Hg means hydrogyrum mercury. So these points are ATM. All these points when you consider anywhere here, pressure due to atmosphere ATM, and here the point is pressure due to mercury because atmosphere is not giving a pressure since there is a column of liquid. So since all of them are in the same level, what I can say now, pressure ATM is equal to pressure due to mercury column. Pressure due to mercury column. Did you understand the point how it comes? Because of the same level and if the drop is by 76 centimeters, by the height of 76 centimeters, what is the pressure given? That is equal to the atmospheric pressure. Until it is becoming equal, until it is equalizing, there will be a drop. There will be a drop. That is why it is dropped down. If you are using any other liquids here, the drop will be different. Until both the sides become equal to the same pressure here, it would be dropped down. It would be dropped down. Did you understand that point? So when we are using mercury, it would be dropped by 24. Look at the words. Drop by 24, remaining left over is 76. So by the 76 centimeters, only it is giving the pressure. It is giving the pressure. So you see here, pressure ATM is equal to pressure Hg, liquid columns pressure. So this is actually taken as H into rho into G. Correct? Why? This is taken as liquid pressure, right? H rho G. Liquid pressure H rho G. And since it is 76, for this we are giving a measurement like this: 76 centimeters H. How much is it? 76 centimeters Hg. How do we read this? 76 mercury centimeters. How do we read that? 76 mercury. Where is this 76 come? Because of the drop. Because of the drop, the remaining leftover is 76. And this is the liquid column giving the pressure here. So 76 mercury centimeters. It is the pressure given by mercury barometer, and this is equal to pressure 88. Pressure 88. And sometimes the question gives you in millimeters. Millimeters. How do you take millimeters? 760 millimeters. Why? 1 meter is 1 centimeter is equal to 10 millimeters, right? 1 centimeter is equal to 1 centimeter is equal to 10 millimeters. So like that conversion also you must do. Okay. So unit conversion, when you consider 76 centimeters HP is equal to 760 millimeters HP. And in meters, how much is it? In meters, should be divided by 100, right? Why? 1 meter is equal to 100 centimeters, right? Then it should be 0.76 meters HP. Do you understand that? Okay, how do you read this? 76 mercury centimeters, 760 mercury millimeters, 0.76 mercury meters. But this is what we use basically. Did you understand? Understand the way it came? So this is called torically value. So add the word torically here. The spellings are there on your tube. It's highlighted in the book. Can you see? TORR, right? Right there. And fill up the diagram. Fill up the diagram, please. Fill up the diagram. Hurry up, hurry up. Not to speak now. This part. Oh, fill up the diagram. Okay. You can take this note in the last page. Can you check? Check out the last page. Do you have space there? I hope you have. There you can write marking from the page number. What is the page number? Current page number 6. From page number 6. From page number 6, you can write. Or if you have space within this, you can adjust and write. Or even at the bottom of that page, can you see? Guys, look at this. Bottom of the page, you have a small space, right? We don't need this space. Divide it by a line. Take a tag here. Okay. From the above activity or from Mercury barometer, write it down. If you adjust this space properly, still you can write it. Huh? This part. You can save your space like this without writing these two statements. Without writing these two statements, what you can write? P-ATM and P-HT. If you write this, you don't want to write these two statements. Same thing. Pressure due to atmosphere is P-ATM. Okay, pressure ATM. Pressure due to the liquid column is pH. Then you can save that space as well. But make it fast. Are you done? Done? Understand what I'm doing? Turning over there. And remember these points, okay? Any other liquids, there will be a downward meniscus. How do you read that? Downward meniscus. This layer is called a meniscus. And this is an upward meniscus for Mercury. Downward meniscus and upward meniscus. Done? Right. So this Mercury barometer, when you are going to take to different places in the country, depending on the height, altitude is what is the word? Altitude, not altitude. 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 Altitude means that is the height from the sea level. From the sea level, what is the height you are going on? Okay, altitude. So when this altitude is increasing, when it is increasing, this pressure decreases. Atmospheric pressure decreases. Okay. That means You are in Colombo, you have a certain pressure, let's say. When you go to the hill country, when you go up, certain level up, you see what happens? Atmospheric pressure reduces. Atmospheric pressure reduces. Why? From the sea level, hundreds of meters you are going up. Hundreds of meters you are going up. So when you go up by number of meters above from the sea level, altitude is increasing. So it is something like this. Look, imagine this is the whole space. This is the whole space. Okay, I'm concerning this point. Now to this point, there is a big air column, right? Above the point, there's a big air column, right? Just imagine this is the whole space, right? There's a whole space. Okay, this point I consider to measure the air pressure. Above this point, from here until the floor there or until the ceiling there, we do have a height of the air column, right? Entire air column will be giving a pressure, right? Right. And then again, look at the table here. The table is down, right? Additionally, this air is also added. Then what happens? Air pressure will be high here, correct? And when you consider a point here, then what happens? This is reduced, right? This weight is reduced, right? So the air pressure at this point will be less. So when you move up, above the air column is reducing. So air column reduces, atmospheric pressure reduces. And this is why when you move into lower area line, okay, there the atmospheric pressure is less for you. How do you recognize that? Okay, cold, wind, like cold conditions and all, that is because of the temperature, right? Temperature and environmental factors. Now, when you are going to boil water, there are some applications. Here it's boiling at 100 degrees Celsius, right? There it can't boil at 100. Then less than 100. It boils at a temperature less than 100. When you measure the temperature and when you heat up, even below 100, less than 100 degrees Celsius, it starts boiling. That means not only the boiling point, even the melting point of ice. Ice melts at 0 degrees Celsius here. Okay. In lower area, like at a higher altitude, ice melts at a temperature less than 0. Less than 0. Just one example. All the substances the same. Solid to liquid, liquid to gas conversion should be at a lower temperature. All the substances melting and the boiling point would be less. And that is why if you have gone for the shops there to buy some sort of, let me say, coconut oil. Coconut oil here is liquid, right? There coconut oil you can't find in liquid state. It would be solid. Have you seen? If you have gone and if you found, if you are buying that coconut oil, you may ask, I'm asking for coconut oil, you are giving me ghee. It seems to be like that. Like ghee we are getting in. Nahi, is it? Seems to be like that. But they say that's coconut oil. Why? It is not in the liquid state because the points are different. It has solidified. It has solidified. So what happens? This is because of atmospheric pressure. Atmospheric pressure change. Did you understand that? It has converted to solid, okay, at a different temperature. So these changes are because of atmospheric pressure is less. Now, what is the highest, the tallest mountain in our country? Mount Hydrostatic. Mount Hydrostatic. Mount Hydrostatic. So in our country, when you consider who should be having the lowest atmospheric pressure? You understand? We don't have Everest in our country, man. Okay. So in the whole world, you consider what is the tallest point? Mount Hydrostatic. Everest. Notice Everest. Okay. Mount Everest. So the whole world, when you consider, at the top of Mount Everest should be recorded the lowest atmospheric pressure. When you take the Mercury barometer, it drops by 75 centimeters, almost opposite of this. Here drops by 22, remaining 76. There it drops by 20, drops by 75, remaining 25. So atmospheric pressure at the Mount Everest is almost 25 Mercury centimeters. 25 Mercury centimeters. Understand? So when you go up, the Mercury barometer drops, and the flow will be less, atmospheric pressure will be less. Clear about that? So this is about the Mercury barometer. Mercury barometer. Okay. Right. I told you another barometer we got. Look at this, guys. This is mainly going up with atmospheric pressure. Atmospheric pressure. The next one we do have Aneroid barometer. What right barometer? Aneroid barometer. Have a look on this barometer and see the parts given there. Look at this. Look at this. Look at this. You see here. Look at this. We have a scale. The scale is what measuring the atmospheric pressure. And a lever we have in a shape of L. Can you see L shape? And here we do have a compressible cavity is there. Cavity means a free space. Imagine now the lip you are taking. This area is a cavity, right? Your mouth. Sorry, your mouth is a buccal cavity. It's a small space, free space, right? So when you take the bottle without water, it's a cavity inside. So like that, a cavity is there here. Okay. Now this is connected to the whole system. Now what happens? This is the point up and down. Air pressure is given. Atmospheric pressure is given. Now when you are keeping this Aneroid barometer here, what is the atmospheric pressure in the surrounding will be acting over this cavity. It will be acting over this cavity. So when it is acting over the cavity here, what happens? As per the atmospheric pressure, the cavity changes the shape, right? Imagine if atmospheric pressure is very high, cavity would be compressed more, right? This space would be compressing, right? Something like imagine of this. You are giving a high pressure mean, it changes the shape. Likewise, this cavity will be reduced if the pressure is high. Now connected to the cavity, we have another point, can you see? And this whole setup is connected, right? Now imagine this space is reducing like this, and this is connected over there. Now it was there at this point. Okay. Now when this is coming down, the mark is also coming down, right? Likewise, this area also moves down, and this setup is also connected. It would be also moving down. Okay. Simple to remember. So this is connected to the lever. Now imagine this is the lever. This is a lever. When you pull it down, what happens? Look at the index finger. It moves like this, right? Correct. It won't be moving down because it's connected over there. It's bolted here. So when you pull it down, like it turns in this way. So the index finger goes in a horizontal way. Correct. To the index finger, whom I'm connecting? I'm connecting a wire like this. Look at this. This is the way it's connected. So when I pull it down, can you see the wire? The string here will be moving horizontally. Can you see that? It's moving. So likewise, when this is pulled down, this will be moving forward. When this is moving forward, the chain will be pulled. Chain is connected to this indicator here. So in this way, indicator will be moving to this direction, showing you the pressure here. Showing you the pressure here. It's a mechanical setup. So this is called Aneroid barometer. What barometer it is? Aneroid barometer. Okay, Aneroid barometer. Right. Could you please label them? Label, what's good there? Hurry up. Right. Fine. We come to the next question now. Not a long diagram. I didn't ask you to draw it. Just write the three terms there. Look at this question now. Look here. Now this type of questions are coming in the paper. Okay. You have to listen. I'm explaining only once. Okay. Mandale ka chalna nahi pata. Right. Look at this. pressure at sea level is 76 centimeters Hg. Taking the density of mercury as 13,600. Here, I told you only once. Okay. Now, let's say the mercury barometer, we used it like this, right? Okay. This was the pressure given by ATA. Pressure ATA. And this is the height. The height of the mercury column is given 76 centimeters. 76 centimeters. 36 centimeters, right? Sea level 76 centimeters, Hg means 76 centimeters. Okay. You want to find out this pressure at this point. Okay. At this point, you want to find out the pressure. Look here. How do you find out the pressure now? Find the atmospheric pressure in pascals. Yeah, here, look. Pressure at this point you want to find. And what we learned earlier, on the same level, pressure will be the same, right? Same level, all the points will be having the same pressure. Now, this is giving you P naught, P ATM, both same. The P naught means ATM, atmospheric pressure. So, what is the atmospheric pressure here? Will be the same pressure at this point, right? And the question is asking you to find out this person. But we can figure out this, right? Why? Using a truth. Am I correct? Right? So, at this point, how do you find out the pressure? You are finding out the pressure using height, density, and the gravity. Height, density, and the gravity. So, look at this. Pressure ATM is equal to pressure due to HT. Pressure due to HT. Am I correct? Correct. All of them are having the same pressure, right? Did you understand that point? Okay. All of them are having the same pressure. So, what is the pressure given here because of the liquid column? Will be equal to the pressure either side. Shazeen, Allah, can you explain? Get up. Get up. Both of you. Shazeen, you are Shazeen, right? Get up. Get up. You are speaking your continuously. On the way, say it. What did you do? That means he spoke to you. Yeah, don't say one line for everything. Speaking lies. Can you see how we escaped now? Get out. Okay, listen to answer. Okay, now. Right. Pressure atmospheric pressure is equal to pressure due to the liquid column. Pressure due to the liquid column. Now, how do I find out the liquid column pressure? H into rho into G, right? H into rho into G. Now, tell me what is the height here? What is the height? 76 centimeters. Can I apply centimeters? I have divided by 100 to make it meters. Correct? Multiplied by what is the density of the liquid now? It's given 13,600. 1000 is given for water. We don't have water. We have mercury. So I have to multiply it by 13,600 kilograms per cubic meter into what is the next one? Gravity. 10 ms minus 2. Give me the answer for this. Draw like this. And remember, one more question is there, so don't just write throughout the space. Separate it into two. Go up and down, separate and do it. Another question is there. To be written answer within the same space. Pressure atmosphere is equal to pressure due to this mercury column. Ht means mercury. Ht is the symbol for mercury, okay? Ht is mercury. Better write it down. Write it down, otherwise you can't remember. Ht is mercury. Hydrogen is the name. Right? Find out the answer. Now don't copy paste, okay? Do it alone. Find out. Once you are done with that, you can find out. Multiply it, go with others. I don't know how many others are using it. I mean, sorry, right? Sir, what is that? Action. Is about action. Is it how we are very Get the next one. What is the answer you got here? What is the answer? 103, 360. What is the unit? Pascals. 103,360 pascals. As I multiplied, no? Show me the answer. Right. Now look at this. Next question says that look at the next question now. These are the find the height of a water column that can be balanced by the atmospheric pressure. Same pressure, guys. Same pressure. You have to balance by what I told you earlier, right? When the liquid is changing, the drop will be changing. Okay, according to the liquid's density, the drop. Now, what are you going to do? That can be balanced. You are going to balance the same amount. You are going to balance by water instead of mercury. This is found by mercury, right? And you are going to find it by water. How do you do that? The pressure ATM 103,360 pascals. You have to balance by what column? Water column. Earlier we took mercury, now we are taking water column. You understand that point? Is that point clear? Earlier you have balanced the ATM by mercury column. Now the question is asking you to balance by whom? What is the height of the water column unit? So look at this. Pressure ATM, we found it as 103,360 pascals, right? Pascals. Okay. How to find out the pressure of water column here? Imagine now this is water. The height is there. This height is what you want to find. Find the height. So how do I take H into rho into G? Correct? Am I correct? H rho G. 103,360 pascal equal height I don't know. Okay. Or let me take like this. Okay. Height. How much is rho? It's 1000, right? Now do we take 1000 or 13,600? 13,600 given by mercury. This is 1000. That is why on the same question is given like into how much is the gravity? 10 ms minus 2. Guys, look at this now. You want to find out the height. Height is equal to 103,360 pascal. Now these two parties you have to take to the other side, right? How do I take? Dividing by 1000 into 10 means 10,000, correct? 4 zeros are there. Okay, 4 zeros are there, right? So 103,360 dividing by 10,000. 10,000. How much is it giving me? 10.336 meters. 10.336 meters will be given. 10.336 meters will be given. Is that clear? Okay. This is actually goes up with the simplifications. Okay. Multiplication, division. It is not important here. Hurry up. Will you write it down? Hurry up. Right. So some applications where we use atmospheric pressure. Atmospheric pressure. Can you tell me some example? What are the points you are using this atmospheric pressure? Path. When you drink water using a straw. Okay. You are using a straw, let's see. Right. What's happening here? Look at this initially. Initially, guys, look at this. When you're gonna take this first, Before using the stroke, okay, before using the stroke, look at this. Usually when you keep a straw here, the water level won't be at this point, right? It will be slightly up there. Have you seen that? Okay, slightly could be up. That is because of the atmospheric pressure given here. PADA. Look at this now. Look here. Now when you are going to use the straw here, when you are going to use the straw, what do you do there? How do you use the straw? Right. You are using the straw here. You have to stop this bottom. What's happening at? Listen. Wait. Listen. You don't know that. Okay. What's happening here? Initially, it was totally water. This was totally water, and this is also water inside. This is also water, but the remaining is air. Can you see? The remaining is air. So either side atmospheric pressure is there. Either side atmospheric pressure is there. So this is the liquid column pressure. Why the liquid has risen up? To make it balance. To balance this point. To balance these 2 points, liquid is rising up. Okay. So the remaining is air. Air gives a pressure. Now when you stop, what happens? The air goes into your mouth first, right? When you use the straw, air goes into your mouth. Correct? Now you see, once the air goes into your mouth, that the space becomes free, right? And the pressure given by that level of air is reducing, right? Correct? Now, out the atmosphere and inside the straw pressure, when you compare, inside the straw pressure, is it less or more? Less. Because air is taken over. Am I correct? So inside the straw pressure is less. So usually gases can move from high pressure to low pressure. If the gases cannot move because of a barrier, gases have the ability to push it. Now what happens? Here high pressure and the gas can't be moving into the straw right because of water. What happens now? This gas gives a push towards this. Look at this. The high pressure here will be giving a push to water. Because of that the pressure will be acting towards these, water rises. So that the water comes towards your mouth. Did you understand that point? So here atmospheric pressure, equalizing the atmospheric pressure is what we are using. Did you understand the point? Is the point clear? Initially it was air here. That air is gone into your mouth. So air pressure reduces. So the inside straw pressure will be less. Outside high pressure gives a push over this level of water. Water gives the pressure to go out, and that the pressure lets the water to flow into your mouth. This is how it happens. Okay. Any drinking straws when you are using, this is how it is working on. Clear? Comes in questions. In part 2 paper they ask you. Okay, part 2 paper they ask you. Okay, I have explained you. Further, you can go for your textbook related to these three examples are there. You can read the textbook. Okay, I haven't given the description on my tube. Okay, because I'm explaining that. Listen, all these are working because of atmospheric pressure. Right. So here, look at this. High pressure. Inside there was less pressure. Because of that high atmospheric pressure, what happened? It gives the push down. A push is given down. So the water transfers that pressure. Right? Fine. Could you please mark it down on the diagrams given? Hurry up. Yes. Yes. Look at the next one. Siphon method. Siphon method. What is the next one? Siphon method. What is the siphon method? Now you are using a water tube. If you want to transfer water from one container to the other container, you are using a water tube and you are transferring water. And sometimes they are also you are doing the same like the drinking straw. Okay, drinking straw activity. But here, what is the theory? Look at this. Look here, Azam. What do you do here? A, we are having a certain height. At a certain height. P is down. And the tube initially, the first step. This does have the water level rate. There's water, and this water is what you want to transfer to the second drop. So the tube, the water tube you are taking here, you have to fill up the water. Initially, both the ends, until both ends, you have to fill up the water. Okay. And what you do? One side you have to close it by your finger. The other side adjustable. Adjustable means one side press up, you have to press it. You have to press it. Where water doesn't come out. The other side also are pressing, and you are going to. Okay, what do you do? You are going to immerse. You are going to immerse. You are going to take one end inside A, inside the first container. The other end is closed like this, right? One end you have put it inside. The other end you are pressing on. Now you have to leave. But you have to do that after you immerse it down. Here you can't. It won't work out continuously. You have to put it down to the bottom. Okay. Then when you take off your finger here, you can see water comes down. Water comes down. So what is the theory behind? The theory behind here is initially at this point when you consider. Okay. This gives atmospheric pressure. And here there is a liquid column, right? Correct? At this point when you consider, so this is the end of the tube, right? It is the end of the tube. So at this point, when you consider, there is a height of the liquid column, right? There is a height of the liquid column, correct? Correct? And the pressure is given by ATM also, right? Okay. So two pressures are there. One is ATM, the other one is due to pressure of water. Pressure of water. Am I correct? So the pressure acting here is at this point. Okay, I'm speaking about this point. The pressure acting here is ATM plus pressure due to water column. Correct? You understand the point? One is above, the other one is below because of this liquid level, liquid column. So here ATM is there, atmospheric pressure is there, and here this level, the water level gives a pressure, that is the water level pressure, liquid pressure, hydrostatic pressure. Now both the pressures together acting at this point. Correct? You understand that? So at this point the total pressure is P ATM plus P water. Now the other side when you consider, you are opening up, right? Is it exposed to air now? Is it exposed to air now? Yes, it is. Why? It's open to air. Okay. Only ATM pressure is there. So at this end, okay, only ATM pressure is there. Is it having a liquid column pressure? No, it's not having a liquid column pressure. You may think that this liquid column, actually that is the liquid column moving down now. Okay. So here the pressure is because of exposed out, only the atmospheric pressure is there. So atmosphere to atmosphere cancels and the additional water pressure because of the liquid above is not acting here. So here the pressure is more. Because of that, here the pressure is more. Here at this point the pressure is less. Here at this point the pressure is less. So to equalize the pressure, due to the pressure given by ATM and this pressure, water moves on. This is why water moving along. So you know how much it comes down? Until both the sides pressure becomes the same. Water moves on. Water moves on. Did you understand that point? Is that point clear? So accordingly, siphon method is also following up atmospheric pressure. Atmospheric pressure. So high pressure to low pressure improves. So you see, whenever you are changing the pressure as high and low, high to low pressure equalizers pushing the object forward or towards the lower one. Towards the lower one. Okay. Label them, please. Label them. I have given you all clearly. You can see P ATM, pressure ATM, and this is the pressure given by water because of the height. Okay, because of this height. And at the point, the cross here, what is the pressure? Total pressure is ATM plus water. ATM plus what? But here you take only P ATM is there. So A is having a high pressure, B is having a low pressure. A is having high pressure, at the point B there's a low pressure. High pressure, low pressure. These are the 2 points we consider. Yes. Yes. Wait. Right. Look here. Now, according to high pressure to low pressure, it transfers. Now they ask like this. Without doing that, even when you are sucking out this air, same thing happen like that. We do right one side, what we do, we suck out the air. So air when it comes out, air pressure reduces. Other side the pressure is high. So high pressure to low pressure, it pushes down so that the water moves on. Water moves on. Right. Next, look at this. A rubber circle. Sometimes that rubber guns, shotguns are there. In your kid's age, what you are playing with that, it goes straight and hits on, it places on the glass mirrors, surfaces and all. What's happening there? Look here. Even the rubber suckers that we are using in the tube systems and all. Guys, look at this. What we do? Now, when it is moving like this, look at this. These are surface. Okay. When it is hitting on into it, only few air particles will be trapped inside. Only few air particles trapped inside. So the pressure inside is less. Because of that, less pressure is there. You understand? Only few air particles are trapped inside. Because when it is moving on, air leaves out. Air leaves out. When it is hitting on the surface, between these two surfaces, one is the rubber surface, the rubber circle surface, and the wall or the mirror. Only few air particles are there, so the pressure is less. Outside the atmospheric pressure, it is high now, relatively. It is not increasing. It is the same pressure, but here the pressure is reducing because of less amount of air. Now you see, high pressure to low pressure, air particles try to move right. And the thing is, there's a layer, rubber layer is there. So what it does, it gives a push on the, there will be a push given by this atmospheric pressure. So because of the push given over there, the rubber sucker sucks over there without, falling down. Now, this is because of outside high pressure, inside less pressure. So that it is holding up, giving a pressure. It is pressing over there. Now you see, sometimes it falls down. Why? But if there are gaps here, then what happens? Then through the gap, the air pressure can move on, right? High pressure to low pressure, air particles can move, right? When the air particles are moving in that way, the pressure here will increase. When it is equal to the atmospheric pressure, okay? When it is equal to the atmospheric pressure, you can see it falls down because no change, no gradient between the air pressure means it can't be holding up. So then it falls down. And when the pressure is increasing because of a gap, because of an exchange, you can see it's getting looser. It's getting looser. And after all, it falls down. After all, it's falling down. That is because of there's a gap between, somewhat because of an error. Yes. So Here, using a rubber circle, exactly you can remove the few air. Anyhow, it will be there. Okay. But after connecting, if you are having a sort of, let's say, a vacuum cleaner or something, somebody are connecting and taking out all the air particles, this rubber circle, fixed pill, it will be kept on there because there is no way the air particles could go on. So it will be kept connected over there, and this area you can see pressed furthermore inside. This area would be pressed furthermore inside. You can observe. Is that clear? Clear about that? So this is how the applications we are taking. One of that part would be taken into the practical questions. Okay. Please mark it down. Mark it down, please. All right. So is that the points clear? Points clear? Fine. So okay. So listen now. Girls, yes, yes, yes. My next week, last week come. Yeah. Now the thing is, I gave you 1 week time to get prepared. The proposal. And 2 more weeks you are having for the exhibition. I think after I got. I think that's the first year. Here we are going to have. I thought the advantage is everyone participating in different topics. You are going to make the models. You are going to make your own. Okay. While you do one, all others you are going to do them on that day. You are going around and do them, and you should be able to explain as well. I told you pick up a topic. Pick up a topic. Okay. For example, imagine, right? Any sort of application like this, you take assignment with it. You are making the model of the assignment with it. Okay. You have to make. You have to make the assignment with it. Okay. Don't come up with a drinking straw and a glass of water and do that. Okay. Then, okay. Don't do those things. As an experimenter, don't be a finished. Okay. Chinese things don't do. You can just browse and check related to light, related to buzz, related to sound. There are many experiments. Okay. They said now we are explaining this. And I've been sending me messages on sometimes. I didn't. There were people sending me messages. I didn't reply with it. I want this one. Okay. You have to listen. Without listening, going on, don't send me messages again. Here. Listen. So, pick up a topic. Make a context. What are the materials you need to make it? What are the steps you have to develop? After very clear. Yeah. Okay. Listen. So, you see, pick up the topic, write the mathematical report. These are what I need, and these are the steps I'm going to put up. Okay. What is the model that I have to draw basics? Okay, and you have to come up with them on that particular day. You have to make things. You have to make everything at home. You have to make what I am going to exhibit. You are going to make the model. You have to bring it on that day. Okay, and you should be able to explain what you need. So for that, I need a proposal. You have to make this is what you are going to do. These are the basic law of resources. Okay, whatever scientific experiment. But at least explain how to do it. Otherwise, I'm going to cancel this. Right? The thing is, not just cancel. I will give another punishment on that. Okay. All your parents are going to do that. Related to this. Okay. Related to this. Along with the different punishment. Then that happens. Because you have to participate. Okay. You have to participate. Okay. This is now. You have to write also whatever you have to participate. Because this is not something you are spending on it, it's meaningful, right? You have to engage them to improve your staff. No, I can also fight. You can take from your whatever the remaining subs are there. Okay, if you are such a person where you are not very sufficient, whatever is there, you can use to make a experiment. Okay, right? Give the comments for your problem. Okay. I give the comments for your problem. Because anyhow you will be late to go. Anyhow you are going home late. He will be giving you a call. That happens every day. Sorry, okay. Right. Listen. That's one. Second thing, I got you next week Thursday. 17 Thursday. Okay. 9:30 to 1. So, 9:30 to 1, we are having a seminar. Morning 4 a.m. Okay. Listen, don't give me results. Everyone must attend. Okay. It's a seminar, but it's free for class. But you have to come up with the October card. Okay. They will check it since it is a 30. Right. So, 9:30 to 1. 9:30 is 9:30 hours. Don't ask me again. Okay. 9:31 you have to be here. 16 chapter I am going to start. This remaining the next class will take. Okay. 16 chapter we are going to start. 16 chapter part will be great. Again, quantity because anyhow it is our last year. We are adding 1.5 hour. We are making the one. That's all. Outside the seminar. Okay, as usual it would be either 800 or 1000 would be the seminar. Okay, as usual I get that right. 800 to 1000 it would be the seminar. But my class will be given. Okay. But make sure you join them. Don't give me a reason to send them. They are that the lesson one be done. It's a chemistry term. It's a chemistry. So chemistry lesson you can't learn it. You can't work with recording as well. So make sure you join. Please inform the friends also have to come to the class. Clear? Once you get the flyer, please share. Please share with all those who want to be they can do it. Here, please make this next. Right? No, it's not like that. It's from grade 11. Grade 11 seminar. He is having the grade 11 seminar in the morning. He is having the grade 11 seminar in the morning, not for grade 10, right? It's grade 11 seminar. Okay. Did you inform them? Grade 10? Very busy. Yes, we did you inform in the class last week? In the prior clearly look at that. He is the 10 and 11 seminar. Check it out. 6 October is the 10 11 seminar. 17 is grade 11. Secret says so. Those who haven't given, please, I'll give them all to all. Listen what I said, right? If there are any errors, correct. Okay. What the thing is what I do?